Hello everyone, today we are going to learn a little bit about linear regression. You definitely need your graphing calculators for this, so make sure you get those out at this time. We are going to start with the definition of a scatter plot. A scatter plot is a graph used to show the relationship between two quantitative variables. A quantitative variable might be a new vocab word for you. Basically, a quantitative variable is a variable that can be measured numerically. Okay, so now let's go to our line of best fit definition. The line of best fit is the least squares regression line. And basically what the least squares regression line is determining the line that is a best fit to the scatterplot data points. Now correlation. Correlation is a measure of how well the data follows a linear model. Okay, let's take a look at these scatter plots. For each scatter plot, describe the correlation as strong positive, strong negative, or little to none. Explain the reason for your answer. So starting with the first one, we basically have points scattered everywhere, all throughout the graph. They don't go anywhere close to a straight line. We have some up top down here, some up top over here, both on bottom on this side. We don't see any sort of linear relationship. So at this point, this would have little to none as far as correlation goes. That means the two variables that we're measuring on these axes would not be very correlated. Let's check number 2. Number 2 is much different. Number 2, all the points are very close together and they form a linear model, as we can see. And this would actually be a strong negative correlation because these points are decreasing from left to right. And finally, the last one, again, all the points are very close together, so this is a strong relationship. Basically, the closer that your points get to forming a line, the stronger the relationship is. So the difference between number 3, they're all very close to forming a line, whereas number 1, they're not close together at all. So number 3 would be an example of a strong positive correlation. Okay, so now let's start by, first of all, clearing our data from the list. So on your graphing calculators, press the Stat button and then Edit. Arrow up to the top of your L1 or L2 list, whichever one has numbers in it, and press Clear, then Enter. Now we're good to go to start entering our information, so make sure that you do that first. So the example problem and dataset that we're working with says that the table shows the percent of U.S. households with at least one computer. We have some years and the percent for those years. So let's make a scatter plot for this data in our calculator. If we're going to make a scatter plot, we need to enter in these data points. We're going to let x equal 0 for the year of 1984. Instead of plugging in for all of our x's, the actual years, 1984, 1985, we'll have a much better representation of the scale and correlation of our data if we use x being the number of years since 1984. So that means the year of 1984 in our calculator will be 0, 1989 will be 5, 1993 will be 9, 1997, 13, 2001, 17, and 2003, 19. Now we're actually going to make a scatter plot. First, before you start by making a scatter plot, please make sure that your y equals are clear. This is really going to throw off the least squares regression line when we get there if it is not clear. So go to your y equals and make sure all 10 of those y equals are clear. Now we're going to start by entering the data into our list. Usually we enter x values in L1 and y values in L2. So in order to get to the list, you press Stat, Edit, and then plug in your x values into L1 and your y values into L2. Once you have your lists made, now we can pull the data from those lists to make a scatter plot. In order to do that, you click Stat Plot, which is second y equals, then hit 1, and make sure that you turn the scatter plot on by pressing Enter. Scrolling down, you pick the scatter plot picture, which is the first option, and then making sure that your X list is pulling from L1 and your Y list is pulling from L2. Then finally, to graph it, a quick easy way to do that would be pressing Zoom 9, and that usually fits a window best for graphs like scatter plots and other statistical graphs. So once you have your scatter plot, now let's find our line of best fit that correlates with the scatter plot. First, we need to turn on our diagnostics so that the calculator generates the R value. In order to do that, you press the catalog button, which is second 0, scroll down to diagnostics on, then press Enter twice. Your calculator will say diagnostics on and then done when it's finished. Now we can start by generating our line of best fit. In order to do that, you press Stat, Calc, the option Lin Reg, that stands for linear regression, and then press Enter twice. From there, you're given an equation that looks like this, y equals ax plus b, but it shows you what two exact values you are given for a and b in order to plug them into this equation. So that's exactly what you're going to do. I rounded to 2 decimal places, so I have y equals 2.96x plus 2.37. It's always a good idea to write this equation down before you start manipulating with this equation in your calculator. Okay, so now finally, let's take our linear regression equation, our line of best fit, and plug it into y equals so that we can graph that line on our scatter plot. Now the best way to do this is to use y vars because this will take your entire equation and not your rounded off version. It'll be more accurate. So you go to y equals, then vars, statistics, which is number 5, then scroll over to equation, it's at the top. Then regular equation, you press Enter, and then finally graph. And then what you'll see is that it places this line of best fit into your y equals, and it graphs that on your scatter plot. So now that we have our graph, let's figure out what this data really represents. Does the data appear to have a linear relationship? Well, yes, of course it does. It seems that all of the data points are very close to the line, so it is a strong linear relationship. Now, what does the slope represent? So let's do a little flashback. Remember that slope-intercept form of a line is y equals mx plus b, where m is the slope. Well, in our linear regression equations, m is the same thing as a. In this case, our a value is 2.96. So let's think about this a little bit. I can take my slope, 2.96, and write it as a fraction over 1. Because when I think of slope, I think of rise over run, which means I think of y's over x's. So what variable is my y? Well, according to my table, y is the percent of how many households have at least one computer, and x is the number of years since 1984. So now this gives me a better idea of how the number 2.96 relates in the context of the problem. And I can say it like this. The percent of U.S. households with at least one computer increased 2.96% per 1 year, because remember my fraction was 2.96 over 1, 2.96% for every 1 year. Okay, so what does the y-intercept represent? Well, first let's write down our equation. We have 2.96x plus 2.37. So let's do a little refresher. That plus 2.37 represents when x is equal to 0. So what does that mean? That means that there were 2.37% of U.S. households with at least one computer in the year 1984, because that's when we determined when x is 0. And finally, you can use your calculator to predict the percent of households with a computer in the year of 2013. So let's take a look. So if you're trying to find a y value at a particular x value, you can do a couple things. First of all, you can plug in the x value, which would be 29 years since 1984, into your equation, and then you would solve for your y value, which would be your percent. Or, given the certain circumstances, you can use your actual graph. So you would just go to second graph and scroll down until you get to the number that you need, which would be 29. So our answer for this question would be 88.21% of households would have a computer in the year 2013. So please make sure that you come into class tomorrow with many questions if you have them, and write down any calculator issues that you have so that we can help you solve them tomorrow.